Now, today's lesson is about transformations, and we're going to begin our conversation of transformations with a discussion of what we mean by the argument of a function. The argument of a function is the input that the function is operating on. So, for example, if we're talking about the equation y equals f at x, the function is f, and the argument is x. If we're talking about the expression g of 3x minus 1, the function is g, and the argument is 3x minus 1. Okay? The argument is the input. If we're talking about the expression 3h of 4x plus 5, the function is h, and the argument is 4x plus 5. 3 is merely something we're multiplying everything by after we've evaluated it. If we talk about the equation y equals f of a plus 4, the function is f, and the argument is a plus 4. When we talk about the expression k of 2/3 n minus 8, the function is k, and the argument is 2/3 n minus 8. Okay? And if we talk about the function 4p of 7 minus 2h, the function is p, the argument is 7 minus 2h. Continuing on, if we have the expression 6 minus f of 2 plus x, the function is f, and the argument is 2 plus x. We're inputting 2 plus x to the function f. Now granted, after we're done that, we'll subtract it from 6, but the function is f, the argument is 2 plus x. In the equation y equals 3f of 2x plus 1 minus 9, the function is f, and the argument is 2x plus 1. And finally, in this last expression, 4 minus an eighth of f of 3 bracket x plus 1, the function is f, the argument is 3 bracket x plus 1. Okay? Now, moving on, we're going to now shift our focus to what we call horizontal transformations. Now, horizontal transformations are determined by values inside the argument. So, for example, in this question here, we've got 3x minus 12 as the argument. Everything we need to know about the horizontal transformations is going to be told to us by this argument. So, values inside the argument determine whether there are any horizontal transformations, but what we want to do is express the argument in the form k of x minus d. Or sorry, k times x minus d. This is a multiplication, my bad. K times x minus d. So we want to express the argument in that form. So let's look at this first example. The function in this is f, and the argument is 3x minus 12. But I haven't expressed that in the form I want. I want it in the form k bracket x minus d. So I'm going to say that that's the same as saying 3 bracket x minus 4. In other words, I'm going to factor out the coefficient of x. So now my argument is written in the form I like, k bracket x minus d, in this case 3 bracket x minus 4. And I can say that the k value is 3, and the d value is 4. And you might be tempted to say that the d value is negative 4, but it's not. It's positive 4, because we've got it in the form k bracket x minus d. So the presumption being this number is negative. So if we have a minus sign here, the value is actually positive. So in this case of 3x minus 12, 3 bracket x minus 4 close bracket, k is 3, d is 4. And we'll discuss in a later lesson what those values have to do in terms of the transformations that will be done to the function. Okay, let's look at this next one. We've got the expression 2f of negative 4x minus 5 plus 2. Well, the function is f, and the argument is negative 4x minus 5. But this isn't the form that I like. We like it to be in the form k, in other words, factor out the leading coefficient, and then x minus d. Well, in this case, we have x plus 5 over 4. So our k value is negative 4, and our d value, since it's x plus 5 over 4, our d value is negative 5/4. because x plus 5 over 4 is like saying x minus negative 5/4. So D is negative 5/4. Okay, and our next question here, the expression is negative 3/8 f of 1/8 x minus 5. The function is f, and the argument is 1/8 x minus 5. Factoring out that 1/8, that's the same as saying 1/8 in brackets x minus 40. Well, our k value is 1/8, and our d value is 40. Okay. And looking at this example, we've got the expression 4h of open bracket 2, open bracket x plus 1, close bracket, minus 9. Well, the function is h. The argument is 2 bracket x plus 1. The k value is 2. And since this needs to be x minus d, we say the d value is negative 1. Okay. Moving on then to vertical transformations. Well, we've discussed the horizontal. The horizontal occurs by everything given inside the argument. So just to show you where I am here, k bracket x minus d establishes the horizontal transformations. Well, sometimes the function is multiplied by a value of a, and sometimes a value of c is added on at the end as well. Well, this a and this c value help us to determine vertical transformations. So to be more concise, the values outside the function and the argument determine whether there are any vertical transformations, a and the c. We multiply the function by the factor a, and we add the value c. Okay, whatever we multiply by is the a, whatever we add is the c. So for example, we have the expression 2f of 7x minus 14 minus 13. Well, the argument is 7x minus 14, and that's really the same as 7 bracket x minus 2. Now we can restate this expression as 2f of 7 bracket x minus 2 minus 13. And so we've got an a value of 2, right there, a k value of 7, a d value of 2, remember x minus d, and a c value of negative 13. Well, this a value and this c value will help us to determine vertical transformations, and this k value and this d value are going to help us to determine horizontal transformations. Okay, looking at our next question. Y equals negative 5f of 4x minus 15 plus 3. Well, I see that the argument here is 4x minus 15, and that can be expressed as 4 bracket x minus 15 over 4. Okay? The expression now is written this way. Well, we can write it as negative 5, open brackets, or sorry, whoop, my bad. Sorry, negative 5f, open up a square bracket, 4, x minus 15 over 4, plus 3. I now know my value of a is negative 5, my value of k is 4, my value of d is 15 over 4, and my value of c is 3. Vertical transformations from these two, horizontal transformations from these two. And in a later lesson we're going to talk about exactly what those transformations are. But we need to be able to arrange the expression we're given to suit our purposes. Okay, this question here, our argument is negative 1/8 x minus 1. Well, that's the same as saying negative 1/8 and then in brackets x plus 8. Okay? And our expression, we see that we're multiplying by negative 3/8 and then we're adding 2. So don't make the mistake of saying 2 minus 3/8 equals 13/8 and then thinking that 13/8 is the a value. No, what really happens is that this 2, this negative 3/8 is multiplying f, so I can think of it as being this 2 is being added on the end I've got negative 3/8 f of negative 1/8 x minus 1 plus 2. So again, here's my expression, negative 3/8 f of negative 1/8, open bracket, x plus 8 plus 2. Okay? So we took that additive value, that additive term right there, moved it to the end where we can kind of see what's happening. We kept the multiplicative factor in front of the f. We factored out the coefficient of x to give us k bracket x minus d, and everything brought us to this point. Our a value is negative 3/8. Our k value is negative 1/8. Our d value is negative 8. We change the sign of what's in that bracket. And our c value is 2. Okay? Next one here. Well, this is actually really put in a nice form for us already. Our argument is 2 bracket x minus 8. And our expression is exactly what's written here. Negative 4h 2 bracket x minus 8 minus 19. Our a value is negative 4, our k value is positive 2, our d value is positive 8, and our c value is negative 19. And now that we know these values, we're going to be able to perform transformations on the parent function really well. Okay, just a couple of more. Sometimes people see the argument switch, the order of the terms switch from what they're used to. That's no big deal. We see here our function is h. Our argument is 4 minus 3x, which is the same as negative 3x plus 4, which itself is the same as negative 3, and then in brackets x minus 4/3. Okay, so we have our argument. So our expression is negative 2h, open brackets, negative 3, open bracket, x minus 4/3, minus 19. This is the input of the function, what we call the argument. It gives us our k value of negative 3 and our d value of 4/3. We're multiplying our result by negative 2, that's our a value, and then we're adding negative 19, or in other words, subtracting 19 from the result. That's our c value. And last one here, this really causes people some headaches. We've got 5 minus f of 6 minus x over 2. Well, our function is f. Our argument is 6 minus x, which is the same as negative x plus 6, which is the same as negative 1, and then open bracket, x minus 6. That's our argument. Now our expression, I'm going to take this 5 and divide by 2, so it's 5 halves. And then I'm going to subtract this. There's a coefficient of 1 in front of the x. Well, now it's minus a half f of 6 minus x, we just said, is negative 1 bracket x minus 6. Okay? And now to put this additive value from the front, to put it behind where we're used to it, and so we can see the multiplicative factor in front of the f, we have negative 1/2 f of negative 1 bracket x minus 6 plus 5 halves. And once we can do all that, we can just cherry pick our a, k, d, and c values. A is negative 1/2, k is negative 1, d is 6, and c is 5 halves. And in a later lesson, we're going to talk about exactly what each of these values does to the graph of the parent function.